Welcome to another training module from CloudMasters Incorporated, and this is the part 2 of Cloud and DevOps Engineer interview questions and answers to ace your interview. Let's continue. DevOps practices. Question 41. What is DevOps and what are its core principles? Answer. DevOps is a cultural and technical movement aimed at improving collaboration between development and operations teams to deliver software more efficiently. Core principles include collaboration, breaking down silos between development, operations, and other teams to foster teamwork. Automation, automating repetitive tasks such as testing and deployment to improve efficiency and reduce human error. Continuous integration and continuous delivery, CI/CD implementing practices that enable frequent code changes and automated testing to deliver updates quickly and reliably. Monitoring and feedback, continuously monitoring applications and infrastructure to gather insights and feedback for ongoing improvement. Question 42. How do you implement CI/CD pipelines? Answer. Implementing CI/CD pipelines involves several steps. Version control. Use a version control system, e.g., Git, to manage code and configuration files. Continuous integration. Set up automated builds and tests using CI tools, e.g., Jenkins, GitLab CI, to validate code changes and detect issues early. Continuous delivery/deployment. Automate the deployment process to different environments, staging, production, using tools like Kubernetes, AWS Code Deploy, or Terraform. Monitoring and rollbacks. Implement monitoring to track deployment success and automate rollbacks if issues are detected after deployment. Question 43. What are the key metrics to monitor in a CI/CD pipeline? Answer. Key metrics include build success rate, the percentage of successful builds versus failed ones, indicating the stability of the code base. Deployment frequency, how often code changes are deployed to production, reflecting the team's agility. Lead time for changes, the time it takes from code commit to deployment in production, measuring the speed of development cycles. Mean time to recovery, MTTR, the average time taken to recover from a failure in production, indicating the efficiency of incident response. Question 44. What is infrastructure as code, IAC, and how does it benefit DevOps practices? Answer. Infrastructure as code, IAC, is the practice of managing and provisioning infrastructure through machine-readable configuration files instead of manual processes. Benefits include version control. Infrastructure configurations can be version controlled, enabling tracking of changes over time. Automation. IAC allows for the automation of infrastructure provisioning and configuration, reducing human error and increasing consistency. Consistency. IAC ensures that environments are consistent and reproducible, minimizing configuration drift. Collaboration. Teams can collaborate more effectively on infrastructure changes, integrating infrastructure updates into the development workflow. Question 45. How do you ensure quality in a CI/CD pipeline? Answer. Ensuring quality involves automated testing, implement unit, integration, and end-to-end tests to validate code changes before deployment. Code reviews. Establish processes for peer code reviews to catch issues early and share knowledge. Static code analysis. Use tools like SonarQube to analyze code quality and enforce coding standards before merging changes. Staging environments. Use staging environments to test applications under production-like conditions before final deployment. Question 46. What tools do you recommend for implementing CI/CD in a cloud environment? Answer. Recommended tools include Jenkins, a popular open-source automation server for building, deploying, and automating software development processes. GitLab CI/CD, integrated CI/CD tools within GitLab for automating builds and deployments. Circle CI, a cloud-based CI/CD platform that allows for rapid build and deployment processes. AWS Code Pipeline, a fully managed continuous integration and continuous delivery service for automating release pipelines. Azure DevOps provides CI/CD services with integrated tools for planning, development, and deployment. Question 43. What are the key metrics to monitor in a CI/CD pipeline? Answer. Key metrics include build success rate, the percentage of successful builds versus failed ones, indicating the stability of the code base. Deployment frequency, how often code changes are deployed to production, reflecting the team's agility. Lead time for changes, the time it takes from code commit to deployment in production, measuring the speed of development cycles. Mean time to recovery, MTTR, the average time taken to recover from a failure in production, indicating the efficiency of incident response. Question 44. What is infrastructure as code, IAC, and how does it benefit DevOps practices? Answer. Infrastructure as code, IAC, is the practice of managing and provisioning infrastructure through machine-readable configuration files instead of manual processes. Benefits include version control. Infrastructure configurations can be version controlled, enabling tracking of changes over time. Automation. IAC allows for the automation of infrastructure provisioning and configuration, reducing human error and increasing consistency. Consistency. IAC ensures that environments are consistent and reproducible, minimizing configuration drift. Collaboration. Teams can collaborate more effectively on infrastructure changes, integrating infrastructure updates into the development workflow. Question 45. How do you ensure quality in a CI/CD pipeline? Answer. Ensuring quality involves automated testing, implement unit, integration, and end-to-end tests to validate code changes before deployment. Code reviews. Establish processes for peer code reviews to catch issues early and share knowledge. Static code analysis. Use tools like SonarQube to analyze code quality and enforce coding standards before merging changes. Staging environments. Use staging environments to test applications under production-like conditions before final deployment. Question 47. How do you manage configuration management in a DevOps environment? Answer. Configuration management can be managed using configuration management tools. Use tools like Ansible, Chef, or Puppet to automate the configuration and management of infrastructure. Version control for configurations. Store configuration files in version control systems to track changes and enable collaboration. Environment-specific configurations. Use templating or parameterization techniques to manage different configurations for various environments, development, testing, production. Question 48. What is a microservices architecture, and how does it relate to DevOps? Answer. Microservices architecture is an architectural style that structures applications as a collection of loosely coupled, independently deployable services. It relates to DevOps by enabling agility. Teams can develop, test, and deploy microservices independently, allowing for faster release cycles. Promoting collaboration. Different teams can own different services, fostering collaboration and accountability. Facilitating automation. Microservices can be easily integrated into CI/CD pipelines, allowing for automated testing and deployment. Question 49. How do you handle logging and monitoring in a DevOps environment? Answer. Effective logging and monitoring involve centralized logging solutions. Use tools like ELK Stack, Elasticsearch, Logstash, Kibana, or Splunk for centralized log aggregation and analysis. Monitoring tools. Implement monitoring solutions like Prometheus, Grafana, or Datadog to track application performance and system health. Alerting. Set up alerts for critical metrics to notify the team of potential issues or anomalies in real time. Question 50. What are some common pitfalls to avoid when implementing DevOps practices? Answer. Common pitfalls include lack of collaboration. Not fostering a collaborative culture between development and operations can hinder DevOps success. Ignoring security. Failing to integrate security practices, DevSecOps, into the DevOps workflow can lead to vulnerabilities. Inadequate testing. Skipping testing phases to accelerate delivery can result in undetected bugs and issues in production. Over-automation. Over-automating processes without proper oversight can lead to issues when things go wrong. Cloud migration. Question 51. What is a cloud readiness assessment, and why is it important? Answer. A cloud readiness assessment evaluates an organization's current IT infrastructure, applications, and processes to determine their suitability for migration to the cloud. It is important because it helps identify potential challenges, gaps in skills, and resource needs, ensuring that organizations are adequately prepared for a successful migration. Question 52. What are the steps involved in a successful cloud migration process? Answer. Steps include assessment. Evaluate existing workloads, dependencies, and compliance requirements. Planning. Develop a migration strategy, choosing the appropriate migration model, lift and shift, replatforming, etc. Execution. Migrate applications and data to the cloud, ensuring minimal disruption. Optimization. Optimize performance and cost in the new environment. Monitoring. Implement monitoring and management practices to ensure ongoing performance and compliance. Question 53. How do you determine which applications to migrate to the cloud first? Answer. Applications can be prioritized based on business impact. Identify applications critical to business operations or those that will benefit significantly from cloud capabilities. Complexity. Start with less complex applications to build confidence and experience with the migration process. Cost savings potential. Focus on applications where migration can lead to significant cost savings or performance improvements. Question 54. What are the potential benefits of migrating to the cloud? Answer. Benefits include scalability, ability to scale resources up or down based on demand quickly. Cost savings. Pay-as-you-go pricing models can lead to lower costs compared to traditional infrastructure. Accessibility. Cloud services can be accessed from anywhere with an internet connection, promoting remote work. Disaster recovery. Built-in redundancy and backup solutions in cloud environments enhance data protection and recovery. Question 55. What challenges can arise during a cloud migration? Answer. Challenges include data transfer issues. Large data migrations may take time and require careful planning to minimize downtime. Integration difficulties. Ensuring that migrated applications can integrate seamlessly with existing systems can be complex. Skill gaps. Teams may lack the necessary skills or experience to manage cloud environments effectively. Cost management. Unforeseen costs can arise if resource utilization is not monitored and managed effectively post-migration. Question 56. How do you ensure data integrity during a cloud migration? Answer. Data integrity can be ensured through data validation, implementing checksums or hash functions to verify data consistency before and after migration. Backup. Taking backups of data before migration to prevent data loss in case of issues during the process. Testing. Performing testing in a staging environment to ensure that migrated data is accurate and complete. Question 57. What are the differences between IaaS, PaaS, and SaaS? Answer. IaaS, Infrastructure as a Service, provides virtualized computing resources over the internet, allowing users to rent infrastructure like servers and storage. Examples: AWS EC2, Google Compute Engine. PaaS, Platform as a Service, offers a platform allowing developers to build, deploy, and manage applications without worrying about the underlying infrastructure. Examples: Google App Engine, AWS Elastic Beanstalk. SaaS, Software as a Service, delivers software applications over the internet on a subscription basis, eliminating the need for installation or maintenance. Examples: Google Workspace, Salesforce. Question 58. How do you perform a cloud cost analysis before migration? Answer. Performing a cloud cost analysis involves identifying costs, estimating costs for resources such as compute, storage, and data transfer, using cloud provider pricing calculators. Analyzing current expenses, comparing current on-premises costs to projected cloud costs to identify potential savings. Considering licensing, evaluating any licensing costs for software that may change when migrating to the cloud. Simulating usage, modeling expected usage patterns in the cloud to determine costs under various scenarios. Question 59. How do you approach user training during a cloud migration? Answer. User training can be approached by assessing training needs. Identify knowledge gaps among users to tailor training programs effectively. Providing resources, offering training sessions, documentation, and access to online courses to help users adapt to the new cloud environment. Hands-on workshops. Conducting hands-on workshops to allow users to gain practical experience with cloud services and tools. Ongoing support. Establishing ongoing support channels, such as help desks or user forums, to address questions and concerns post-migration. Question 60. What tools do you recommend for cloud cost management post-migration? Answer. Recommended tools include AWS Cost Explorer, allows users to visualize, understand, and manage AWS costs and usage. Azure Cost Management provides tools for analyzing and managing Azure cloud costs. Cloud Health, a multi-cloud management platform that helps organizations manage cloud costs, performance, and security. CloudCheck offers cloud management solutions focusing on cost optimization, security, and compliance. Kubernetes and containerization. Question 61. What is the role of a Kubernetes master node? Answer. The Kubernetes master node is responsible for managing the Kubernetes cluster. It runs the API server, ECT, the key value store for cluster data, the scheduler, and the controller manager. The master node coordinates the worker nodes, maintains cluster state, schedules pods, and handles API requests from users and other components. Question 62. What is a pod in Kubernetes, and how does it differ from a container? Answer. A pod is the smallest deployable unit in Kubernetes, encapsulating one or more containers that share network resources, IP address and ports, and storage. While containers are the actual runnable instances of applications, pods provide a higher-level abstraction that allows related containers to work together. For instance, multiple containers within a pod can communicate via localhost, making it easier to manage tightly coupled applications. Question 63. How do you handle application scaling in Kubernetes? Answer. Application scaling in Kubernetes can be managed through Horizontal Pod Autoscaler. HPA automatically scales the number of pod replicas based on observed metrics, such as CPU and memory utilization. Manual scaling. Use the kubectl scale command to manually adjust the number of replicas for a deployment or stateful set. Cluster Autoscaler. Automatically adjusts the number of nodes in a cluster based on resource requests, ensuring that there are enough resources to handle the workload. Question 64. What is a service in Kubernetes, and how does it facilitate communication? Answer. A service in Kubernetes is an abstraction that defines a logical set of pods and a policy for accessing them. It provides a stable IP address and DNS name for communication, enabling reliable access to the underlying pods. Services can be of different types, such as cluster IP, internal access, node port, external access via ports on each node, or load balancer. Integrates with cloud load balancers for external access. Question 65. What is the purpose of Helm in Kubernetes? Answer. Helm is a package manager for Kubernetes that simplifies the deployment and management of applications on Kubernetes. It uses Helm charts, which are collections of files that describe a related set of Kubernetes resources. Helm allows users to install, upgrade, and roll back applications easily, providing templating capabilities and version control for application configurations. Question 66. How do you implement network security in a Kubernetes cluster? Answer. Network security can be implemented through network policies. Define rules that control the traffic flow between pods, allowing only authorized communication and enhancing security. TLS for ingress. Secure communication by enabling TLS on ingress resources to encrypt traffic between clients and services. RBC for network access. Use role-based access control, RBC, to manage permissions for users and services, restricting access to sensitive resources. Question 67. What is a config map in Kubernetes, and how is it used? Answer. A config map is a Kubernetes resource that stores configuration data as key value pairs, enabling decoupling of configuration from application code. Config maps can be used to inject configuration data into pods as environment variables or mounted as files, allowing applications to be more flexible and easily configurable without changing the container image. Question 68. How do you troubleshoot a failing pod in Kubernetes? Answer: troubleshooting. Check pod status. Use kubectl get pods to check the status of the pod and identify if it's pending, running, or failed. View logs. Use kubectl logs pod name to retrieve logs from the pod's containers for errors or issues. Describe pod. Use kubectl describe pod name to view detailed information about the pod, including events that may indicate why it's failing. Resource quotas. Check if resource quotas are being exceeded, which can prevent pods from starting. Question 19. What are some best practices for securing APIs in the cloud? Answer: best practices include authentication and authorization. Implement strong authentication mechanisms, e.g., OAuth, JWT, to secure API access. Rate limiting. Use rate limiting to prevent abuse and mitigate DDoS attacks. Input validation. Ensure that all inputs are validated and sanitized to prevent injection attacks and other vulnerabilities. Monitoring and logging. Implement logging to track API usage and anomalies, allowing for quick detection of potential security issues. Question 20. How do you manage secrets in a cloud environment? Answer: secrets management strategies include dedicated secret management tools. Use services like AWS Secrets Manager, Azure Key Vault, or HashiCorp Vault to securely store and manage sensitive information. Environment variables. Store secrets in environment variables to avoid hard-coding sensitive information in the code base. Access controls. Implement strict access controls to limit who can access secrets, ensuring that only authorized users and services can retrieve sensitive information. Question 69. What is the Kubernetes API and how does it facilitate cluster management? Answer: the Kubernetes API is the primary interface for interacting with the Kubernetes control plane. It facilitates cluster management by allowing users and components to query and manipulate the state of resources, e.g., pods, services, deployments, through RESTful calls. The API server processes requests, validates them, and updates the ECT key value store, ensuring that the desired state is maintained. Question 70. How do you ensure high availability in a Kubernetes deployment? Answer: ensuring high availability involves multiple replicas. Deploy multiple replicas of pods to ensure that if one fails, others can handle the load. Pod disruption budgets. Define pod disruption budgets to manage the number of pods that can be taken down during voluntary disruptions. Node affinity. Use node affinity and anti-affinity rules to distribute pods across multiple nodes and zones, reducing the risk of a single point of failure. DevOps practices. Question 71. What is continuous integration, CI, and why is it important? Answer: continuous integration, CI, is the practice of frequently merging code changes into a central repository where automated builds and tests run to validate changes. CI is important because it helps catch integration issues early, improves code quality, and accelerates the development process by providing rapid feedback to developers. Question 72. What is continuous deployment, CD, and how does it differ from continuous delivery? Answer: continuous deployment, CD, is the practice of automatically deploying every code change that passes automated testing to production without manual intervention. In contrast, continuous delivery ensures that code is always in a deployable state but requires a manual decision to deploy to production. The key difference is the level of automation in the deployment process. Question 73. How do you manage dependencies in a CI/CD pipeline? Answer: managing dependencies involves versioning. Use semantic versioning for libraries and dependencies to ensure compatibility and stability. Dependency management tools. Utilize tools like NPM, Maven, or Bundler to handle library dependencies and ensure they are included in builds consistently. Automated dependency updates. Implement automated tools, e.g., Dependabot, to keep dependencies up to date and secure. Question 74. What is a build artifact, and how is it used in CI/CD pipelines? Answer. A build artifact is a file or set of files generated as a result of the build process, such as compiled binaries, Docker images, or configuration files. Artifacts are stored in repositories, e.g., JFrog Artifactory, Nexus, and used in the deployment process to ensure that the exact version of code that passed testing is deployed to production. Question 75. How do you implement security in a CI/CD pipeline? Answer. Implementing security involves static application security testing, SSD analyze code for vulnerabilities during the development phase using automated tools. Dynamic application security testing, DSD performs security testing on running applications to identify vulnerabilities. Secrets management, use secure methods for managing secrets and credentials in the pipeline, avoiding hard-coding sensitive data. Compliance checks, incorporate compliance checks into the CI/CD process to ensure that deployments meet regulatory requirements. Question 76. What is GitOps and how does it relate to DevOps practices? Answer. GitOps is a modern approach to managing Kubernetes deployments using Git as the single source of truth for declarative infrastructure and application configurations. It enables developers to manage infrastructure through Git workflows, improving collaboration, traceability, and disaster recovery. GitOps integrates seamlessly with DevOps practices by automating deployments and providing visibility into changes. Question 77. What are some common metrics to track in DevOps? Answer. Common metrics include deployment frequency, how often new releases are deployed to production. Lead time for changes, the time taken from code commit to deployment in production. Change failure rate, the percentage of deployments that result in failures or rollbacks. Mean time to recovery, MTTR, the average time taken to recover from a failure in production. Question 78. What is the role of containerization in DevOps? Answer. Containerization enables the packaging of applications and their dependencies into lightweight, portable containers that can run consistently across various environments. This promotes consistency. Applications run the same way in development, testing, and production environments. Scalability. Containers can be easily scaled up or down based on demand, aligning with DevOps principles of agility and responsiveness. Isolation. Each container runs in its environment, reducing conflicts between applications and enabling efficient resource utilization. Question 79. How do you handle legacy applications in a DevOps environment? Answer. Handling legacy applications involves assessing compatibility, evaluating the legacy application's architecture and dependencies to determine the best approach, refactoring, replatforming, or containerization. Incremental refactoring, gradually refactoring parts of the application to modernize it without requiring a complete rewrite. Containerization, packaging legacy applications into containers to improve deployment and scalability while minimizing changes to the underlying code. Question 80. What are the benefits of using microservices architecture in a DevOps context? Answer. Benefits include independent deployment. Each microservice can be developed, tested, and deployed independently, reducing the impact of changes on the overall system. Scalability. Services can be scaled independently based on their resource needs, optimizing resource utilization. Resilience. Failure in one microservice does not necessarily bring down the entire application, improving overall system reliability. Faster time to market. Teams can work on different microservices concurrently, accelerating the development process and enabling faster delivery of new features. We appreciate your continued support, so remember to subscribe to our channel, like our videos, and share them with your network. Thank you for choosing CloudMasters Inc.